Okay, so at this video we'll be talking about counting sample points, or this is a continuation of our discussion in probability, wherein we're gonna be discussing about how to count sample points and how to predict the number of outcomes that a given situation could have. Okay, first we have here definition of a rule. So that is the counting rule or the multiplication rule. So if an operation can be performed in n sub 1 ways, and if for each of these ways a second operation can be performed in n sub 2 ways, then the two operations can be performed together in n sub 1 times n sub 2 ways. Okay, so this rule basically means that, for example, if we have a certain if we have a certain set of sample points, for example, we will call our sample points as n1, okay, n sub 1. Then n sub 1 has its own combination or has its own number of outcomes. For example, this is color, so three colors: red, blue, white. Okay, then we have also another set or another event wherein the sample points are, for example, numbers. So have 1, 2, 3. So this one. So the number of ways in which we can get the combination of these two is given as n sub 1 times n sub 2. So basically it is equal to this one, 1, 2, 3. So this is 3. This is also 1, 2, 3. So that is 3. So that is times 3 times 3. This is 9. So if you are going to have the sample space of that one, the combination of that one, okay, so we will have, for example, we have red 1. Then you can also have blue 1 and white 1. Then we can have red 2, blue 2, and white 2. Then we have red 3, blue 3, and white 3. Okay. So if we will count our sample points or our element, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically we have 9 ways. So this counting rule is a method in which we are going to know how many sample points are present in the given sample space. So if we are going to extract that one, or we are going to write down the sample space, so basically the number of sample points that we have is equal to the number which is solved using this multiplication rule. Okay, so we have here an example. In how many sample points are there in the sample space when a pair of dice is thrown once? Okay, so let's have our solution. So we have a pair of dice, so therefore we have two dice, so that is a pair of dice. So that the plural for die is dice. So we have our n sub 1. So if we're gonna throw a single die or a die, then the outcome of that will have 6, no? Because the number of a die is numbered from 1 to 6. So we have 6 possible outcomes for the first die. For the second die, we have also 6. Now, if you are going to get the possible outcomes of the two together, so that will be n sub 1 times n sub 2. We could just write that one as n sub 1, n sub 2. So we have 6 times 6. So this will be 36 ways. So this is the answer. Okay, we go to the next. A developer of new subdivision offers prospective home buyers a choice of Tudor, Rustec, colonial and traditional exteriors styling in ranch, two-story, and split-level floors. In how many different ways can a buyer order one of these homes? Okay, so basically we are on the business of real estate, no? So the problem states that a buyer could choose two types of styling, exterior styling. So we have Tudor, and it's not two but four types of exterior styling. So we have Tudor, rustic, colonial, and traditional. So that is four, and those style could be applied if the buyer will buy a ranch, a two-story, or a split-level floor plans. So we are going to get in how many ways can a single buyer choose, no? How many possible choice that the buyer could have. Okay, so we have our solution. So first, our n sub 1 is the number of choices on the style that a buyer could have. So we have Tudor, rustic, colonial, and traditional. So this will be 4. The next is the type of building or the type of floor plan. So we have two-story, ranch, two-story, and split floor level plans. So this is 3. So the total number of ways that a buyer could choose, so we have 4 times 3, and this will be equal to 12 ways, and this will be our answer. Okay, next, so we have here, if a 22 member club needs to elect a chair and a treasurer, how many ways can these two be elected? Okay, so we have here a problem in which we are going to elect a member, 2 members of a club into a chairman and a treasurer. So we are going to find out in how many ways could we elect those for those 2 positions. Okay, so solution. So our first position to be elected is the chairman. So that will be our n sub 1. So for the chairman, we have how many members we could elect. So we have 22. Okay, 22 members. So that will be 22 ways. Now the second position will be for the position of treasurer, and how many members could we elect or could we nominate? So that is the correct term. Could we nominate for that position? So because the position of a chairman had been already been elected, so therefore for the position of treasurer we have only now 21 members, because that one member has been chosen for the position of chairman. So in a certain club we could not have a certain person that could have 2 positions. So if you are going to be elected for that position, you cannot run for another position. So that is the concept that we are going to apply in this problem. So for the position of treasurer, we have only 21 members that we could elect. It could go other way around. For example, if for some cases that that a certain club decided to elect first the treasurer, so for the position of the treasurer you have 22 members that could be nominated. Then after that one, they will go back, or they will now elect for a chairman. Then you have the number of members that could be nominated is now only 21, because the one has been elected as treasurer. So the number of ways that the position of chairman and treasurer can be elected from a 22 member club is n sub 1 times n sub 2. That is 22 times 21, and that will be equal to 462 ways. Okay, so if you are going to have the sample point of this one, the actual elements of the sample space, then maybe you will have the for example, we will get all the names, the 22 names of the members of the club. Then for example, Jerry is elected as president, then Mary for treasurer. So we will have 462 different combinations on the ways we could elect the chair and the treasurer. Okay, so next, now we have another rule. If an operation can be performed in n subways, and if for each of these a second operation can be performed in n sub 2 ways, and for each of the first two a third operation can be performed in n sub 3 ways, and so forth, then the sequence of operation can be performed in n sub 1 times n sub 2 ... n sub k ways. So this is a somewhat hybrid rule for the multiplication rule. So for example, if you have n sub 1 could perform in n sub 1 way, so that is the first event. The second event can be performed also in another way, or it is dependent to another event. But the total number of choices you can have, the total number of ways that that all of those events can be performed is given with this one. So n sub 1, n sub 2, ... up to the last sequence that we are going to, or up to the last event that we are going to consider. Okay, so maybe we should have an example for this one. Okay, so Sam is going to assemble a computer by himself. So he has the choice of chips from 2 brands, a hard drive from 4, memory from 3, and an accessory bundle from 5 local stores. So how many ways can Sam order the parts? Okay, so Sam is, I believe he is a computer technician. So he has the choice of first the chips, so 2 brands. So for example, that is one of those brands is Intel, the other one is IBM. I don't know, but you have two. Some can choose from 2 different brands of chips or microchips. Then for the hard drives, we have a choice of 4 brands. For the memory, we have a choice of 3 brands. And for the accessory bundles, so maybe the cover, the fan of the computer, so he has a choice of buying that one from 5 local stores. So how many ways can Sam order the parts? So how many choices does he have to order, or how many combinations, or how many instances could he order the parts? So maybe he will buy a certain brand for the chips, certain brand for the drive, the memory, and order a certain store for the accessory bundle. So that is the question for this example. Okay, so we have here our solution. Okay, so for the chips, so we have that one as our n sub 1, so that will be 2. So we have 2 brands only, so he has only 2 choices. Then for the hard drive, so that will be n sub 2, so he has only 4 choices, 4 brands. Then for the memory, n sub 3, so we have only 3 choices, 3 brands only. And for the accessory bundles from 5 local stores, so that will be n sub 4, that will be 5. Okay, so the number of ways could he order the parts, so that is the multiplication rule of these 5 events. So we have 2 times 4 times 3 times 5. Okay, so maybe now we will use our high-tech calculator in this one. Okay, so we have 2 times 4 times 3 times, I believe I pushed 2 times 4 times 3 and times 5, and this is equal to 120 ways. Okay, so he has a choice of 120 ways. So there are 120 ways he could order the parts of the computer that he will going to assemble. Okay, so we proceed to another example. So how many even 4-digit numbers can be formed from digits 0, 1, 2, 5, 6, and 9 if each digit can be used only once? Okay, so we are going to find how many numbers, 4-digit number that can be formed from these given digits 0, 1, 2, 5, 6, and 9. So even, and because it is even, there is no repetition. So if each digit can be only used as once. Okay, so let's just first analyze this one solution. Okay, so if we have a 4-digit number, so 4-digit number, so we will use 4. So we have N4, N2, so this is just N3, N2, and N sub 4, N sub 1, sorry. Okay, so for N sub 1, this will be our units place because we are 4-digit, no? This will be our tens, this will be our hundreds, so just put here hundreds, and this will be our thousands. Okay. Okay, so that is how we are going to analyze this one. Okay, so 4-digit even. So even, if you are going to consider even, therefore your units place must be all even. So for the choices of even, we have only 1, 2, 3. So 3 numbers that you could use to produce an even 4-digit number. That will be 0, 2, and 6. So basically you have here 3 choices. Then the other one, because you don't need to have a repetition for this one, so you have 1, 2, 3, 4, 5, 6. So the first one will be used for this one. So you have here the, how many that? 6. So you have already deducted this one here. So this will be now only 5, 4, and 3. But in case that the one here will be 0, so you will be using here only 2. Why? Because you cannot have a ones digit for or the thousands place for 0, because it will now be only a 3-digit number. So this is how we're going to analyze this one first. But remember, we could have really consider the thousands place. So we need to have here the different approach for our solution. So first, we will consider that our N1, okay, so that is the first condition. Okay, so we have here condition 1. Our N1 is 0. So 0. So the position for the units place is 0. So therefore, our N1 will have only one choice, that will be 0. Then we will go to N2. So N2, okay, so sorry for that, it's not N2 but N4. So for N4, we will have, so we will first consider the thousands, because the thousands is mostly critical. Okay, so N4, so N4 we have, so we have already got the 0 from N1, so we have here 5. Then for N3, we have 4, and for N2, we have 3. Okay, so our first condition, so our N4 times N3, so now we will form our 4-digit number. So we have here 5 times 4 times 3 times 1. Okay, so using again our calculator, so we have 5 times 4 times 3 times 1, so we have 60. Okay, so this is equal to 60 ways. So that is for the first condition. So we have 60. Now for condition number 2, so our N1 is not equal to 0. So we could use only 2 and 6. So for N1, we have 2 possible combinations. For N4, so it is we will eliminate 0, so therefore we have only 5 choices for N4, so that is 1, 2, 5, 9. Okay, but our 2 and 6 could be used for N sub 1, so N sub 1. So therefore, for example, if 2 is being used for N sub 1, we will now have only 1, 5, 6, and 9 for the thousands place or the N sub 4. So we will now have only 4 choices. So the reason that is this is not 5 because we will not consider 0. The reason that it is 4 because the other one had already been used for this one here. Okay, so this will be 4, and our N sub 3, so because this is 4, could also have this one as 4, will include the 0. And for N, because this is not only the hundreds place, and for N sub 2, so this will now be equal to 3. So our combination here is N sub 4, N sub 3, N sub 2. Okay, so let's just write legibly our N sub 3, N sub 2, and N sub 1. So this will be equal to 4 times 4 times 3 and times 2. Okay, so let's have our calculator. Okay, so I believe I have covered this one with the calculator. Okay, so let's just calculate that one. So we have 4 times 4 times 3 times 2. Okay, and this is equal to this is equal to 96 ways. And because these two conditions are mutually exclusive, so the total number of ways for this one, so for example, we'll call this one as let's have here this one as N sub A, and this one is N sub B. So the total number of ways, we will have that one as A plus B. So because they are mutually exclusive, we cannot use plus because that will be a inclusive. So N sub AB, so we have here N sub A plus N sub B. So we have 60 plus 96. So we have let's just have our calculator. Okay. Okay, so let's just put our calculator in its right place. So 60 plus 96, so we have 156. So this is 156 Okay, so that will be our answer for this example. Okay, so that will be all for this video, and thank you for watching, and as always, have a good day.